All right, folks, welcome to week 5 of DAX 601. This week we're going to cover visualization using the ggplot2 package. It's part of Tidyverse, part of the Tidyverse universe. There are other ways to plot, but in this course we focus exclusively on ggplot. So in video 1, we'll have ggplot2 and its basic building blocks, as well as univariate analysis. In video 2, we'll go over multivariate analysis and layers, and then in video 3, we'll talk about communication in forcats, which is the package for factors. So let's start with ggplot2. Like I said, this is a tidyverse way of visualizing data. ggplot2 has a few basic building blocks. The two main ones are aesthetic mappings, which are variables to be plotted, and geometric objects, which are the type of plot that you want to use. So we've got bar charts, line charts, box plots, and so many others. When it comes to building up a visualization, there's a few steps that you have to follow. The very first step is to call ggplot, to say, ggplot, I want to visualize something. Just type out ggplot and then two parentheses, just like you would any other function. Your next step is to define the data that you're going to use. So you have to tell ggplot, okay, great, I want you to run, and this is the data that I want you to run on. In our case, we're going to work with the penguins data as well as some others throughout this example. So ggplot data equals penguins, or whatever your data is. The next step is to tell ggplot what visual properties of your data you want to map. And by that, I mean what X or Y or other variables that you want to map. So you say, okay, data is penguins, but within penguins specifically, I want to plot the flipper length as X and the body mass as Y. So here, I've explicitly said data equals penguins. I've set mapping equals these specific aesthetics. So when you think aesthetics, just think variable. The next step is to tell ggplot what type of plot it is that you want. So do you want a scatter plot? Do you want a box plot, a bar chart, whatever? In this case, we are using a scatter plot. So you call a scatter plot with geom_point. And I want to note as well, every time you add in a new layer or the next step, you're going to use a plus. So after that first ggplot call, everything subsequent to that will be a plus. Very similar to how we use piping, where we use the pipe. Instead of a pipe, when it comes to ggplot, we just use a plus. So our next step, you can stop there. You'll have a graph there, but you can add more aesthetics, you can add more variables, and you can also add more layers. So color, shape, size, lines of best fit, labels, annotations, things like that. It's important too that you understand global versus local level mapping. So when you define a global variable in that very first ggplot aesthetics call, that is going to be applied to all subsequent layers. If you define a local variable, that's only going to apply to the individual layer. So let's look at this example. Here, color, we've mapped to species. So in the initial ggplot call, in the aesthetics, we say color equals species. And because color is defined as a variable at the very beginning, subsequent portions of the graph also treat species as something special. So here we have 3 different lines of best fit in accordance to each individual species. Now, if we define this at the local level, instead, we just get one singular line of best fit. So rather than saying color equals species in the very first call, instead when we call geom_point, that's where we're going to say, okay, here color is going to be species. And don't worry, I have example code that we'll walk through to explain this. So sometimes if you're getting errors with your graph, that's something to check. Do I actually want this to be a global variable, or do I just want it to apply for one level? Let's go to our code. So here, as always, we have our libraries at the beginning. I'm guessing that you don't have a bunch of these installed, so make sure that you uncomment the lines of install packages, install everything that you need, and run those libraries so that your code can work. I'm going to walk you through those individual steps. First, when you're visualizing these GG2 building blocks, first you're going to call ggplot, and you'll see it pops up in the plots window. So here it just pops up pops up something blank. We're saying, hey, we want a graph, but we haven't populated it with anything. We haven't added any layers. Our next step is to define the data. Now, you don't have to explicitly type data equals. You can just say ggplot_penguins, and it would know that the first argument is data. For my first few examples, I make it explicit just so that you can keep track of what's going on, but eventually you'll see where I don't actually explicitly use data equals penguins or whatever data I'm using. Here, this doesn't do anything to my graph, but it has given ggplot the information it needs. It knows what data it wants to look at. And I should note, again, penguins is part of the Palmer Penguins package. I haven't had to read it in via a CSV file or anything like that. Now our next step is to map our aesthetics or assign our variables that we want to be placed on this graph. In this case, our X is going to be our flipper length and our Y is body mass. Again, you can search $penguins and see all those variable definitions pop up. But here, when I plot that line, we see, okay, great. We have automatically X and Y axes added. RStudio and ggplot, they go through and they automatically calculate those scales, although we'll talk about later how you can adjust them. Now we have the blueprint or the background on which our graph can be plotted. Our next step is to say, okay, I want this to be of a particular geometry or the particular type of graph. Because these are both numerical variables, we want this to be a scatter plot, which in ggplot is geom_point. And again, every new layer after this very first call that identifies the data and the mapping of the aesthetics, every additional layer has to come after a plus. Just like when we're piping, every additional step comes after the pipe that indicates then. So here you can also read this as ggplot, open the penguins data, map X to be flipper length, Y to be body mass, and then, if that makes it easier. So let's go ahead here. We've told it, okay, this is the geometry that we want, and now here we have our scatter plot. You can stop there. This is a graph. We've plotted something, but you can always add more aesthetics and layers. So in this case, we're going to add in color. Color is really, really helpful to use in our graphs, so it's great to add in here. I'm adding this as a global variable, as an argument within my first aesthetics. So you see, all I've done is just said color equals species. Great. ggplot automatically adds in a legend that makes it clear what each color corresponds to. I'm also going to add in a smooth curve to show the relationship, a line of best fit. Now, if I am plotting a scatter plot, 99% of the time, I am going to be adding a line of best fit just because it makes your data a lot easier to interpret. For this example, I'm explicitly saying method equals linear model just to show you the different arguments that we have. So when I say, okay, add geom_point and also add a layer that's a line of best fit, this is what we see. And now this is where, when we think about global versus local variables and local mappings, this is where that's important. Because I've said color equals species at the very beginning, now every subsequent action is going to be broken up based on the species. But let's say I just want a single line that represents all of the data as a whole without being broken down into that species category. Here is where I'm going to map color at the geometry level, at the level at which I claim a scatter plot. Sorry about that, click the wrong button. Here we go. So let's change that, and you can see why it's really important to think through where you want these variables to go, what type of graph you want to create. Now, it's not just color that we can add. We can also add in shape. So here, again, at the local level, I've adjusted color equals species, and now shape also equals species. So here, that can make it easier for someone who's colorblind, or if, maybe this is printed out in black and white. Here we go. We also have that fail-safe of different shapes for different species. And then here, I'm also adding in different labels. Now, in some of my examples, I might not have labels for everything just for the sake of time and space, but for your challenges and for your final, I absolutely want to see labels. Labels are a really key component of our graphs. So here, this is the exact same code as what you see above, but I've added in a title, a subtitle, X and Y labels, and I've also labeled the legend. And I also use an argument that's called scale color colorblind. Excuse me, that's a function, not an argument. And this is just a palette that's colorblind friendly. And that's from GG Themes, one of the packages that I had you load above. Great. So here's a complete graph. We have our title. It tells us, okay, body mass and flipper length. You could also indicate the direction of the trend. I say that it's dimensions for these different types of penguins. And again, we have a colorblind friendly assortment of colors, and color and shape both indicate different species. And our X and our Y axes, I know exactly what units are being used. Now here's an exercise from the book. In this lecture, in this example, I use a lot of examples from the book just to give you as much support as I can. Here, I'm from section 1.2.5, I'm taking exercise 8. If you open up the book, you'll see that the challenge was to replicate a specific example. What I'm doing is I'm first opening up the penguins data set, so that's what this graph was plotting. So just like what we've done previously, I say penguins and then I pipe. From there, I open ggplot, I say, hey, I want this to be a graph. I map my aesthetics, and you'll notice I don't say mapping equals aesthetics. I just type AES and specify flipper and body mass. Now it automatically knows that your X comes first and your Y comes second. I add a plus to add another layer. That's where I specify that I want this to be geom point, so I want this to be a scatter plot because these are both numerical variables. Here is where I define my color because I want a line of best fit plotted by geom smooth to go across all the data rather than being broken up by species. And then I add in some labs. So this wasn't part of the example in the book, but like I said, I want you to get into the practice of adding in labels. So I create a title, subtitle, X and Y axes labels, and when I specify color, that goes on top of the legend. So here we go. Here's just another simple example. So you can see these are the basic steps. Now let's go back to our slides to talk about univariate analysis. So univariate analysis is the first part of your challenge this week. So here, when you're visualizing the distribution of an individual variable, that is univariate analysis, just one variable analysis. There's two different variable types that we're going to talk about. The first is a categorical variable. Now we've talked about these before, but just as a review, a variable is categorical if it can only take one of a small set of values, if there's specific categories that go with the variable. If you want to visualize a categorical variable, you're going to visualize that distribution with a bar chart. So bar charts, I'm sure we're all familiar with them. Here we go. We have species on the x-axis, and then count is typically what's going to be on your y-axis. And I can see that we have the most penguins are of the Adelie species, and I apologize if I'm saying these penguins' names wrong. Our least popular species is the chinstrap. So this is just a helpful breakdown if you have maybe one type that's like way overrepresented in the data, or is it an even spread or what? This is how we figure that out. Now, a numerical variable. A variable is numerical or quantitative if it can take on a wide range of numerical values, and it's sensible to add, subtract, or take averages with those values. So think of that as count or mean value or standard deviation, something like that will be numerical. I don't think of that as the categories that are represented as 0, 1, 2, 3, right? Because those are associated with a specific category. So when I think of numerical, I'm not thinking of the cases where we have a column that has 0, 1, and 2 that we then recode to represent different values or different levels of a particular variable. I'm thinking of things like mean as numerical. And when you want to visualize this distribution, you're going to use a histogram, a density plot, or a box plot. Now, both histograms and density plots are going to show modes and skew, whereas a box plot will show outliers. So if you want to do a univariate analysis of a numerical variable, one of these three will be your best bet. It's important when we think about histograms to play around with the bin width argument. Now, there's not a single bin width that's the most correct. It really is entirely based on the data that you have. In this case, we've set bin widths to be 20. So bin width means like this is the width of X values that we're going to take in this, and it pops up the individual bars for those. And you can see that those are really, really itty bitty little bins, that it doesn't really tell us much about our data. And on the flip side, if your bin width is too large, here we have an example where it doesn't really show us any particular trends. So here, bin width of 200, we see that that's a pretty good mix between the two. Again, there's not one perfect way. I can't tell you everything should be 100. Play around based on your data. Find something that's too small, find something that's too large, and then try to play around with something in the middle. Typically, when I'm playing with bin widths, I always adjust by units of 10 or hundreds. That's how I like to do it. And so with these, we can see sort of the distribution. We can see what direction it skews in. We can see that it looks like there's a mode right there on the left, and it doesn't look like it's bimodal. It doesn't look like there's a bunch of values or a high count at two different values. These are the things that we can see with histograms. And the same thing with a density plot. Rather than the individual bins, here we just have a curve that shows all of them. It shows us the same thing, that we have a sort of peak mode here towards our left, and we can see the direction that the data skews in. Now, yeah, that's great. That's modal distribution and skew is what we get from histograms and density plots. Sorry, I adjusted my brightness and suddenly could see myself. Now, outliers. You can also use a box plot to see where your data distribution lies, and here it's really helpful if individuals, so two individual dots there, they don't really fit in with the rest of this distribution. So you can see, okay, the average or the median is somewhere between a little under 25, but here I have two observations that are above 40. So these in conjunction with each other can show, okay, are all of my data kind of clustered around a single value, or is it spread out across many values? Now, I don't expect you to know much more than that. You're going to dig into distributions and things like that in later courses. At this point, I just want you to play around with generating distributions for your data. So let's go ahead to our code for this section, and that will be it for this video. So again, let's play around with our bin width example. Here, we specify ggplot. We say, hey, we're making a plot. Specify our data, again, penguins. And we specify our X variable right in that beginning aesthetics. Here, we're just plotting a single variable. It's just body mass, which is numerical. We want to use a histogram. So our options are either histogram, density plot, or box plot. We're using a histogram here. And here we just play bin width equals 20. So that's how we set that argument. And I've set specific titles just for our purposes so that we know what bin width we're using. So here, again, this is where we see this bin width that's really, really tiny. We can make that a little wider. We go the opposite direction. If we set this to 2000, that's where we see we only have 3 bins, and that just feels like it's a little too general. And we switch it to 200. And here we go. This is about the size of bins that we're looking for. Here's an exercise, section 1.4.3, exercise 4 in the book. Here it asks us to make a histogram of the carat variable of the diamonds data. So if any of these data sets, if you're curious about what these variables represent, question mark, we see diamonds. We've worked with this particular data set before. What we're going to do is plot ggplot. We're going to say our aesthetic. We're mapping our X aesthetic to be carat. And then we're going to set our bin width to be 0.01. So how did I figure out what bin width should I do? What I do is I look at my x-axis. I look at the variable, so in this case it's carat. I see the carat ranges from 0.2 to 5.01. And so I say, okay, I need to somehow evenly split that one up. I start with 0.01, again, purposefully making this too small just for the example. I see, that's tiny, that's lots of jumps, that doesn't seem to be too informative. I move all the way to 1, which I guess will be too big. Yep, again here, not as bad. We see a bit more of a trend, but it's still a bit bulky. And so now let me try 0.1. Again, I'm reducing this in units of 10 or 100 is typically my mode of attack. And this is actually the same bin width that was used in chapter 25 from last week. And that's it. That's it for our first section, your basics of ggplot and a little bit of univariate analysis.